exam.
Sir, 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 recording start agada.
Yes, sir. Yeah, madam.
It's already. So, sir, we couldn't change your schedule, sir. You asked me to change the schedule for one day and the next day. So already I got approval, na, sir, like that. So continuously
No,
I got it.
not an issue, madam. I will try my best. I will try my best, madam. But
Okay, sir. Thank you, sir. Shall we start?
uh, yes, madam, you ensure that everyone has joined because 72 participants. We can
Still, they
take.
have to join, sir. They have to they have to
Yeah. We
join.
can wait for 5 minutes and like
Okay,
this.
sir.
Then we'll
We
start.
will. Okay, sir. Okay, sir. We will start.
हेलो सर अटल अटल एफडीपी ले रहा हूँ एक तो सर रिजॉल्व हो गया ना आपका फिर
Good evening, everyone. Welcome to the day 3 of our technical session of AICT ATAL FDP, online 6-day FDP on emerging trends in artificial intelligence for smart innovations and sustainable technologies in Industry 4.0. So we welcome today's our speaker, Dr. Akash Saxena, sir. We welcome you, sir. Thank you all the participants for joining us once again and actively being part of this FDP. It is my great pleasure to introduce our distinguished resource person for today's session, Dr. Akash Saxena. Sir is currently serving as Director of Training and Placement and Professor in School of Engineering and Technology, Central University of Haryana. Sir holds MTech and PhD from Malviya National Institute of Technology, Jaipur. So it gives me proud to say this, that is, sir is been recognized as one among the top 2% scientists in the world in the field of artificial intelligence and ranked by Stanford University and elsewhere, based on sir's quality of his publications and citation counts. So his major research areas include soft computing, computational and artificial intelligence with a specialization in optimization theory. Sir is also senior member of IEEE and fellow of IETE. So the biodata, when I saw it, it is more than 50 pages. So I just picked up 1, 2, 3 points over there, sir. so
Thank
so we
you.
are very grateful for to you, sir, for accepting our invitation and being part of this FDP, sir. Sir will be delivering today 2 sessions. First session, that is session 5, 6 to 7:30 p.m. Mathematical thinking and Python simulations for scalable AI model development. And from session 6, that is 7:30 p.m. to 9 p.m., sir will be handling hands-on MATLAB session on vector operations, probability distributions, and data visualizations. We are very much honored to have such a highly accomplished academician and researchers with us. So, sir, we warmly welcome you and request you to take over the sessions.
So, first of all, Namaskar, Jai Hind to everyone.
Thanks, sir.
It is my pleasure, and it is like coming back to home because PDA College of Engineering Principal Sir, Madam, and Asapalli Sir, they are very far from me, but they are part of my family. So when I was there at PDA College of Engineering, I felt there is a positive vibration in this in the campus. I observed students, I observed teachers, I observed the working culture, and I found that there is some amount of positivity in everyone. Everyone wishes to learn, everyone wishes to work, and I hope this collaboration will be in coming years it will be growing like anything. So I will be starting with my topic on scalable artificial intelligence. And when we talk about the scalable models, we always talk about how the memory and how other programmable logics will be responding towards the scalability. So this is my prima facie concern that I can somehow I could address all these issues in the span of 1.3 hours, 1.5 hours. So if anyone can confirm that, let me see, let me share my screen with you. So I will be sharing my whole screen, and let us see. So can you see my first slide?
Yes, sir. Yes, sir. It's on.
Yes, sir.
Okay. Okay. So shall I keep this video off, madam?
Okay,
Or
sir. Okay, sir. Okay, sir. It's okay.
yeah. So sometimes it will make me conscious that how how I will be presenting. So I will be putting this off webcam whenever it is required. I will be keep it on.
Okay, sir.
Okay. So this is the current topic which I am actually I've told to deliver this mathematical thinking and Python simulation for scalability of the AI model. So also, I would like to thank AICT for organizing such kind of events so that we can actually know each other, we can share the knowledge. So my lecture will be, it would be more of knowledge sharing, and I would like to have two-way communication if possible. So if you are having, if you are not, understanding anything, you may, go to, you may interrupt me and you can go with them. So first, with the first slide, in this slide, I would like to, define a foundation model of AI, which is related to interlinking of different type of data to the different type of task. And in between, there is a link which is known as foundation model. So when we talk about data, so this data is what? This data is actually two type. One data is, we know that it is a unimodal data, and another data we can say this is multimodal data. So when we talk about an array like 1, 2, 3, like this array. So this array is containing of digit. So 123 is a digit representation of this array, and it may be it may be anything, but it is represented by the number of digits. But when we talk about a video signal, then what will happen? This data can be segregated into many parts. So this video have picture, this video has sound, this video has maybe text, some text information is there, and maybe some language related or speech related part will be there. So this particular data is having multiple aspects. So I can see that this data is multimodal, and sometimes while dealing with the multimodal data is quite difficult. That's why we talk about the scalability. So there are two type of scalability. First type of scalability is vertical scalability. Second type of scalability is horizontal scalability. So this is the segregation, like some data is available in text like newspaper. Some data is structured data, some data containing speech, 3D signals, maybe waves, current signals, voltage signals, maybe some transforms, wavelets. And the last one is like images. So images can be from traffic images, maybe medical or health related images. So all these data is in this particular part, all type of data is actually mentioned over here. So there are many more type of information and data, but majorly we deal with this kind of data and AI models. Now let us see in two ways. So with the help of foundation model, So this is foundation model where we can do the innovation, or we can, put up the research. So this research can be, imbibed in this particular part, and multiple models can be found, multiple modeling techniques can be coined, and then we adapt for, particular task like information as extraction. So this 1, 2, 3 is what? So this 1, 2, 3 is what? This 1, 2, 3 is the data which is related to, any rank of a student in AICT examination, NEET examination. Like this rank can be, we can, just a minute, let me adjust this. Now this is a rank, or this may be, anything like price of 1 liter petrol. So this information can be extracted from the part. Now, recognition, so like if you want to do some classification, so you can recognize object. So like I want to recognize a apple, so I would be doing that. Then we can have a set of instruction, which instruction should be followed. We can do this kind of task. Now, image captioning, sentiment analysis, and questioning answering, all these things we can actually done. So the sentiment analysis, we can have one case study on sentiment analysis, and I will tell you how to conduct this sentiment analysis, and a beautiful research project we will be discussing on this in the later part of the this lecture. Also, this chatbot questioning answering. So questioning answering, like responsive to the chatbot. So in my class today, I will be discussing that how a tree algorithm comes in the existence. So these tree type of structure, when a human is asking, he wants to take admission. So starting node is like with chatbot, this is starting node, and then this chatbot is asking, okay, in which part you want to take exam, UG, PG, integrated course, and PhD. So it said I want to take admission in UG. So again in UG we are having CSE, we are having ECE, we are having ME. So let's say I want to take in mechanical engineering. So in mechanical engineering, if you want to go to some special quota, then a special quota is there. If you want to go to TFWS scheme, that is there. And if you want to unreserved category, that category is also, according to this, if you can see that this is, how the, search is going on. So from level 1 to level 2 to level 3. And now this is the result node that I'm in UR category and I want to take admission in the UR category. So accordingly, in UR category, you will be getting seat. So this is how, questioning, answering with the chatbot, all these things can be happen. So the important part is that integration of NLP, natural language processing, and ML applications and advanced AI applications. Actually, these applications require that this foundation model should be scalable. So what is the prima facie requirement? That foundation model shall be scalable. So this is how actually the foundation model is actually working. Now, if you want to take some foundation models of AI, so the foundation models of AI can be depicted in generative pre-trained transformers. You only look once, computer vision based algorithms, and generative models. So generative pre-trained transformers actually. Now we are dealing with GPT-5, but in early 2018, first GPT-1 was launched, then GPT-2, GPT-3, and if you just see that number of data points considered for the consideration, so in 2018 to 2020, if I make a graph, so this is the evolution of GPT-1, and 2022, let's say it is GPT-4, and amount of data actually which is employing for training, and this is year and this is data. So if you see this graph, it is monotonically increasing. So monotonic increasing. So why it is monotonically increasing? Because with every passing year and with every passing generation, more data is collected. So from here, we are transferring the things. We are, we are dealing with the big data. That means the size of data and the modality of the data is changing with every passing year. So if you see that if you are dealing with the traditional neural network, so the computation complexity, time complexity, all these things are actually quite important factors to be considered, because we cannot if you trying to compare an old age scooter of 1998 with jumbo jet or with some F-16 planes, you would be seeing that there is no comparison. So when the data and the problem associated with the data is actually increasing and it is having monotonically increasing trend, then what to do? Then what we need to do? We need to introduce some of some of the algorithms which are capable for dealing with such big data. So that's why we are having some DBNs, deep belief neural networks. Now, the latest LLMs, large language models, are like GPT-5, GPT-4.5, and some advanced computer vision related algorithms like residual network and visual geometry group implementation. So that's how foundation of models of AI actually changed from 1998 to 2002, then 2002 to 2005, and then 2005 to 2025. So I believe that with every passing year, this data is actually multifold. It is multifolding, and the application of big data analytics and the application of big data analytics to handle and design of the framework which can handle the big data analytics is actually acutely required in current times. So that we talk about foundation models of AI. Now, let's discuss the scalability. So if you see over here, this particular part is horizontal scalability. So this scalability is horizontal scalability, which says that in this particular part, in this, let's say this is like 2014, this is 2015, and this is 2000, let's say 2025. So what is happening? So for delivering better performance when the size of the system is increased with more resources. So we say that a database scales vertically when it is able to provide more throughput with a bigger computer in terms of CPU and memory. And also a database scales horizontally when adding more nodes to the cluster yields more throughput. So here we are having one machine, we are having 1, 2, 3, then 1, 2, 3, 4, 5. Then horizontally we are adding more nodes to the cluster. That's why we call it horizontal scalability. Now, when we talk about vertical scalability, you just see this, the size of the particular unit, number of clusters are not changing. Number of clusters, machines, not changed. But size of the machine is increasing. So that's why I say that this is the vertically scalable system. So what is throughput? Throughput is like the data is incoming and the data is outgoing. Response time, that a query is coming and you are resolving the query. So the time taken when you receive the query and you resolve the query, it is known as response time. And throughput is like a load on the system. So for testing the scalability, what you need to do, you need to evaluate response time. You need to evaluate what is the throughput. You need to evaluate what would be the memory usage, what would be the network usage, what will be the CPU usage. So scalability testing, that means whether the system is scalable or not. How we decide? We decide based on the response time, based on the throughput or load testing. So it is nothing but a process to determine the maximum load after which application crashes and users are not able to access the system. So that is how we, construct a load testing. Also, we can have the performance testing. It is a type of non-functional testing that is done to measure the responsiveness and stability of the system under a particular workload. Simultaneously, the scalability testing is it measures the minimum and the maximum load at all levels, software and hardware database, and the goal is to determine whether the system is able to handle more users or not. So if the system is failed in the scalability testing, we say that the proposed framework, or the framework under consideration is not able to handle the data, and this scalability is actually failed for this particular system. So that's why the scalability system is quite important. Now, without much ado, I will be coming on the Python framework. So Python framework is quite important, a big hi to this, because the first thing, it is user friendly. So when you are working with the Python interface, you need not to run the whole program once. You can run it in small segments. So it is also it ensure the productivity is ensured, and loyal community, loyal community. That means the responses, code sharing, and help and debugging is actually possible because the interface is used on internet, and it's kind of open framework. Like this, I said free access and interpreted language, all these are actually connected. So here in this case, we are having less coding. That means more shells, as well as more programs, and more clusters are available for different applications. So it is industry friendly thing. Now it is compatible with different languages. So the part of an NLP, natural language processing, different language it can understand. So this different languages can play a multiple it plays a crucial role, and it serve the purpose that the Python benchmarking is actually going for a global platform. Like we are having numerous libraries for different applications, and it is a dynamically typed language. So these are the benefits of the Python. So whatever framework we are establishing, and these frameworks are having these much attributes. So this framework is automatically scalable, plus convertible to different languages, plus adaptive, and above all, it is user friendly. So this is how Python is actually doing very well in implementation of these kind of things. Now, from beginning to begin with, let us take one very small example of this. Just a minute. Let me check if you are having any question. No, no questions. So let us take introduction to some SVM support vector machines. So I'm taking this example. So we'll try to build this SVM with Scratch. So what we are having right now is a typical data which is can be a two class data. So SVM is originally two class separator. Now with this, let me take one example. So let us imagine room. So this room is full of full of 150 people. So we are having two experts. This is expert number 1 and this is expert number 2. So example how SVM works. SVM works, or let's say there are multiple people here. The objective is find two clusters in the room. This is the objective. Now, expert 1 is having knowledge of gender. So it says total 150 people. So it says, it gives the answer, my two clusters are 75 male, 75 female. But now this expert 2 is having not having any knowledge. So it says, my answer is, we are having two clusters, 75 people, or let's say 65 people are less than 5 feet height, and remaining 85 people are greater than or equal to 5 feet height. So my two clusters are there. Now, what is happening over here, that this particular man is having knowledge of this. That means this particular framework is considered as supervised learning framework. So this is actually doing classification. And here, this particular is not having, supervised learning framework. So it may be considered as unsupervised, but it is using height or Euclidean distance in some of your cases to segregating this. So this is class 1, this is class 2, this is class 1 according to expert 2, and this is class 1 according to expert 2. So This is what, this is clustering. So this example actually showcase how the supervised and unsupervised structure is actually calculated. So here in this case, what we need to do, that we are having two classes and we are having, these two types of data. So one data is this, second data is this. So support vector machine is a supervised machine learning algorithm. That means it knows the label. Labels are known. That means it knows it is expert one. He knows that some of the candidates are males and some of the candidates are females. And what they do, they try to classify an regression task. They try to find the best boundary, which is known as hyperplane, that separate different cases of the data. Here in this case, this is the hyperplane. This can be also hyperplane. This can also be hyperplane. But what we do here, that we try to, develop an optimization routine in such a way that the Euclidean distance between this hyperplane and the nearest and farthest point can be adjusted in such a manner that the Euclidean distance can be maximized. So this is how the hyperplane can be. Likewise, you can also develop an optimization algorithm where you can minimize the for the multi-class classification, you can minimize the farthest point with the hyperpower plane. So this is a linear discriminator where the hyperplane is linear. So this linear algorithms actually works in this. Now, let me talk one important thing also. In this case, I will add one here. Now, can you see this slide? Please reply. Can you see this blank slide?
Yes, sir. Yes, sir.
Okay. So
Yes,
you
sir.
can,
Yes, sir.
okay. So this, now, what is happening in this particular part, that we talk about how we discover a hyperplane and how this actually SVM is a two part class separator. So in some time, what we can have data like this. So we can have this hyperplane. Okay. But at some time, what happened? Data is like this. So this is a classification problem. This is also a classification problem. Now, here in this case, what I need, a boundary like this. So this is what? This is non-linear boundary. Non-linear boundary which can separate two of the classes. Now the point is, every time if I want to deal with this kind of data, and with every, if this is a data related to medical or healthcare data, or maybe I am, doing classification between cancerous cell, then if I do some mistakes and I remove, some of the good cells, and vice versa, if I leave some of the bad cell in the chemotherapy, what will happen? The cancer can grow again and again. So what I require over here, I require a transformation. So let's say y is equal to 1, y is equal to 2, y is equal to 3, and let's say it is going on. Now, what I do here, so let's say this is a cluster and all these points are, here, cluster 1. If I do some kind of transformation like 2 to the power y, so what will happen to this cluster? So this 2 to the power 1, 2 to the power 2, 2 to the power 3, so it is equal to 2, it is equal to 4, it is equal to 8. Likewise, if I do e to the power y or e to the power minus y, you will find that the Euclidean distance between these 2 points are increasing. That means somehow if I, make this series like this, and if I can increase the difference between these 2 points, then definition of this non-linear kernel will be more easy. So here, this type of transformations are known as kernels. So up in simple language, without much ado, simple language, these are some mathematical adaptation, and we use these because we want to increase the Euclidean distance between the data points. So the objective of this transformation over here, this 2 to the power y, e to the power y, e to the power minus y, to change the Euclidean distance in such a manner so that we would be able to define a classifier in a very efficient manner. Now, let us talk one more example where we talk about multi-class SVM. That means, see, if in a very short span, if I want to discuss, simple two-class separator, so it won't be easy and it won't be go with the idea of scalability. So what we need to do, we need to discuss this multi-class SVM, multi-class support vector machine, so that we can have a big idea, and for the larger database we can select it. So the first thing is one versus all, and the second thing is one versus one. So till now we know that SVMs are what? SVMs are nothing but a two-class separator, or it is acting as expert one, which is having some domain specific knowledge, and it can be trained. More data can be used for training, and later on these SVMs will be providing the classification database to us, and it will originally a two-class separator, but what happened when we are dealing with the multi-class SVM? So let us take one example of multi-class. So what is multi-class? Let's say I'm having that this person, multi-class class VN, SVN. So if this teacher wishes to divide a whole class into 3 categories, so what he will say that these students are excellent, A grade, A or A plus. Some of the students are good, B, B plus. Some students are very hardworking, but they will be learning, and the learning rate can be improved in subsequent days. Some students require more attention, and some students require attention of parents, attention of peer groups, and special attention of the different teachers. So here we are having class 1, here we are having class 2, class 3, class 4, and class 5. Accordingly, we divide a class of 50 into this 7, 13, 13, 7, 10. So class of 50 can be divided into this. So 20, 20, and 10. So the first class is having 7 students. second class is having 13 students, third class is having 13 students. So this is how we do the classification. Now, for making a SVM for this kind of application is quite challenging. So that's why what we do, we adopt two type of techniques. So we are having, this is class 1, this is class 2, and this is class 3. So let us take an example of this. So what we do here in this case, 1 versus all. What we do, we pick class 1 only, and we left class 2 and 3. Then we pick class 2 and we leave class 1 and 3. We pick class 3 and we leave class 1, 2. So this is 1 versus all. So what we do in this case, if I want to explain, I will explain like this. So what I will be doing, so I am, a search engine or search agent of SVM. So what I will do, I will make a tree structure like this. So I will start. How many students are having 85% attendance? Marks greater than 85% and remaining else. Here I am having 7. So class A plus. Now with the remaining, how many are having percentage between 75 to 85? So I will be having 13. And remaining, I will leave. Now, in this node, how many will be having between 60 to 75? 75 to 60. So I will be having 13 again. So like this, if you can see over here, what I am doing, I am comparing 1 versus all. That is how the tree is actually going on. So let me see the slide. So 1 versus 1. Let us talk about 1 versus 1. So this 1 versus 1, I am actually what I am doing. I'm trying to segregate one class from one class, one class from one class, one class from one class, and one class from one class. Total number of trained classifiers are n into n minus 1 by 2, and here we will be having 3 classes and 3 classifier will be done. So here we are having 5 classes, 5 classifier will be done. 5 classifier will be created. This tree structure will go up to 5. So, but if I wish to do the comparison between these, so it is having higher complexity, slower training time, and it use voting mechanism. It is sensitive to balanced data, and it used when accuracy is required. So what is imbalanced data? Let's say imbalanced data. So this is the assignment. When I will be taking, break, you have to code the examples. This is the assignment. Code the examples of imbalanced data. Madam, please type this in chat box, and we will evaluate the candidates how they will be, producing this imbalanced data. So let's say I will give you one example data. So data is like I am having bank transaction. So how many bank transaction in a day can be categorized in a fraud, and other can be normal transactions? So most of the time, bank protocols and safety protocols are quite high. So this is quite high data, and fraud data is actually very less. So when when we're dealing with such kind of data, then making a tree and making a classifier from this kind of data is quite difficult, because the data which is abundant, the data which is large, majorly comes in a particular category, and it's quite difficult to deal with it. Now, if you talk about 1 versus all, so it is having lower complexity, faster training time. It selects class with high score, more robust with imbalanced data, and used when simplicity is acquired. Now let's see and take this example, that how I can having this n into n minus 1 by 2 class. What will be having, let's say total number of classes are 5. So 1, 2, 3, 4, 5. So N5 into 4 by 2. So total number of classifier will be 10. So let's see excellent versus good. Then excellent versus hardworking. Likewise, it will be going. So this excellent will be coming 4 times. Then good will be coming 3 times. Then hardworking will be coming, more 3 times. And total classifiers will be up to 10. 10 classifiers we will need to make for this 1 versus 1 implementation. So this is how we develop, a multi-class SVM for this approach. Now, if you do the comparison between this 1 versus all and 1 versus 1, so the strategy can be computationally efficient as the number of generated binary classes is only equal to the number of unique class. So n is equal to 5. So the number of classifiers are equal to 5. So 1 versus all, just see versus all is like this. So number of classifier, but in this case, 1 versus 1 classifier, it grows quadratically as the number of classes increases. So this is n into n minus 1 by 2 for 5 class problem. So 5 into 4 divided by 2, that is equal to 10. So 10 number of SVMs are required here. Here 5 SVMs required. Now it is a struggle, may struggle metric wise because of overlapping classes, different classes in a data set sharing similar features. So this 1 versus 1, 1 versus all, little bit problem this where the classes are overlapping, but it is robust in case of imbalanced data because it is clearing with 1 versus this is 1 versus all. This is 1 versus 1. That means here in this case, I'm having 5 class and data imbalance. So the 5th class is actually, the imbalance data. So what I'll do, I will compare 1 class with remaining 4 class. So 2 class with remaining 3 classes. 3 class with remaining 2 classes. 4th class with remaining classes. Here in this case, what will do 1 versus 1? So this is good data. This is good data. This is good data. And this is, unbalanced, less data. Good means good amount of data. This is good. This is good. Good less. So here in this case, imbalance, data sets may be struggle. So your assignment is to quote some example of imbalanced data in the chat box, and then we will be discussing what is this imbalanced data. Now I will come to the implementation, Python implementation. For this, what I take a simple data over here, which is related to, which is having 7 target class. Okay, so this is a type of forest cover. So sample, these are the samples, these are the features. The data is available in the machine learning repository, and we are using one sklearn library for calling the data. So what you can see over here that the continuous features, the features are elevation, aspect, slope, horizontal distance to hydrology, vertical distance to hydrology, horizontal distance to roadways, hill shade, and categorically binary features are also there. So total number of features are, categorically features are 44 and remaining features are 10. Now, what we are doing in this particular part, if you compare this 1 versus 1 and 1 versus all confusion matrix, you will find that here how to read confusion matrix. Problem is, this is the true level and this is the predicted level. So if you see this level here, so this level belongs to class 0, both predicted and true. So when we evaluate this 3887, so it says that 3887s are total, true levels available in this cell. and predicted labels are also. That means this part of classification is actually perfectly good. That's why what we do, we go diagonally in the confusion matrix, and we evaluate diagonally. That means this is 6, this is 6. So the row is 6, 6. That means this is 6th row and 6th column. So this 6th row says the true label is 228, and 6th column says that predicted label is also 228. So what they are indicating, 1, 1, 2, 2, 3, 3. These all diagonal elements are indicating true labels and predicted labels. So when we are comparing the overall accuracy of this, we found that 1 versus all confusion matrix, slightly, this particular 1 versus all confusion matrix is high. So the accuracy here, you can plot it like this. So this is 1 versus 1. So it is 0.71, 71%, and this is 73%. Like this, slightly it is high. So if you change the data set, the accuracy may be changed. Now, if you can see, if we can, just see the Python implementation of this. Let us check out Python implementation of this. So, madam told me that yesterday you were having, a class on this particular part, and some of the Python programs you must be knowing. So that's why I'm not touching all these Python programs. Directly, what I'm doing, that I will be using, this pre-tuned program, which is available on Anaconda program, Anaconda
Okay, sir.
interface, Jupyter interface. And simultaneously, you can have all these codes I will with you, and you can run these codes. Now, here
Okay,
you can,
okay, sir.
okay. So, can you see the Python interface, madam?
Yes, sir. Yes, sir.
So, this particular part, थोड़ा थोड़ा बताता जाता हूँ मैं साथ के साथ, है ना?
Hmm.
जस्ट गिव ए मिनट, मैंने आपको शेयर किया है. लेट अस सी पाइथन
सर
प्रोग्राम.
हम ग्रुप में शेयर करें क्या? आप अगर ये कोड अगर भेजे तो आप बता रहे थे ना कुछ.
यस, आई विल सेंड इट मैडम. अभी एक बार आप, मैं दिखा देता
है,
हूँ.
अच्छा अच्छा,
And I will
ठीक है,
write,
ठीक
I
है
will
सर.
annotate, and I
ओके,
will be trying, I will sharing these codes. Definitely, I will share.
ओके सर, ओके सर.
Okay, okay. Madam, unfortunately, my pen is not going here, but हाँ, कोई बात नहीं. Let us see, let us see. So we are having, देखिए, don't worry about these big programs. What this particular part is doing, it is importing some of the, some of the part which can be useful for importing the training and testing, splitting of the training and testing data set. Here we can have, some processing units. Here we can have some support vector machine classifier, then 1 versus rest classifier, and accuracy score, confusion matrix, and all these things are actually available in this. Now, when you run this particular program, you will find here, you can see here, I'm calling this data like XY. I'm calling this data, and true and false value I can fetch from this data. Now, for computational efficiency, we can sample a subset of the data. So here, what we are doing, don't worry about this code. It is just for the training and testing of the data. And what we are doing here next, that we are trying to scale the data. Okay. Now, what we are doing here, that I am taking a particular kernel which is having a certain mathematical property, is linear function. And now what I am doing, I'm trying to make it one versus all approach. And here in this case, what I'm doing in second part, I will be doing one versus all approach. And in the later part, what I'm doing, one versus all approach. So this is how confusion matrix can be done for the one versus all confusion matrix. So it is coming 0.7119. And here in this case, it is coming 0.7229. So let me run this program. Let's say, so if you want to run it, shift enter. You need to calculate shift enter. So whenever you are running the program, it will show a star part over there. So, till this start part is showing in your program, that means the is compiling it. Now what happened? Now in second cell, what I will do, I will try to run this program again. So in this second cell, it is showing a star. That means the program is running. So when this execution is completed, I will be having my confusion matrix. So let us observe the confusion matrix in this case. So here in this case, it is not coming, but after running the program, definitely it will be coming. So let us wait for some time. Let the execution will be, let the compiler do the calculation. Let's see what happens. And the last one. Basically, in this program, what I am demonstrating is when your data set is having multiple classes, how to make a framework compatible, which is originally a two-class separator, to a multi-class classification. What we do, we try to arrange some of the units. That means in some cases, we are trying to deal with, we are having a vertical scalability infrastructure in this, because the number of nodes which we are implementing is increasing. So here, horizontal scalability we are doing. But in case of certain neural networks, what you will do in certain neural networks, you employ big data on same structure. In that case, what we can say, that we are dealing with the vertical scalability. But here in this case, number of SPMs are substantially increased. I think it is taking time, so I will be coming back on this. Let us see. One data set which is known as iris data set for classification. So this iris is what? Iris is iris's data is consist of 150 samples. So number of samples are 150. And it is coming from the flowers like versicolor, setosa, and virginica. So the number of classes are 3. Each sample is actually separable with the help of sepal length, sepal width, petal length, and petal width. So like this, you can classify all these 3 classes. So these are the potential features, and the classes, number of classes are 3. So from this slide, what information you will be getting? So information is what? Information. So we are talking about 3 classes. That means originally it is a 3-class problem. Now it is having sample. So it is not a big data analytic problem. So number of samples are large. So we need less memory. We need less compiler requirement. Also, we are having certain features which can be utilized for defining these class. So what we are having four features, like 1, like 2, like 3, and like 4. So number of features are 4 features. So with the help of 4 features and 150 samples, we can divide this problem into 3 parts. The first part is whether the iris is versicolor, whether iris is setosa, and whether iris is virginic. But I remember the title of the talk. So if you are dealing with this kind of data, it's not a big data. We don't need any scalability here. The thing we require here in the scalable AI is that we need to deal with the class which is multi-class. That means the number of classes are 3. So what we require 3 SVM here, minimum 3 SVM. So if I'm implementing 1 versus all, so I require 3 SVM, and if I require 1 versus 1, 3 into 3 minus 1 by 2, that is also equal to 3. That means for 1 versus all and 1 versus 1, I don't require, I will be achieving similar amount of accuracy, almost similar. So that's why the data which is having less number of samples, the data which require same number of machines or same number of clusters, same number of framework for the classification cannot be used for the test of scalability. That's why that's why that's why this fetch COVID type comes in picture. So this slide is very important slide. So it says it is having 150 samples low. It is having more than 5 lakh samples high. 4 numeric features, 54 features. 3 classes, 7 classes. Small, simple multi-class classification, large real-world multi-class classification. All continuous. It is a mixed, continuous, categorical, and one hot coded. Shape of X, 150 by 4. Shape of X, that means training data. That means the input, 58012, 54 categorical data. Memory size, very small. It requires large memory. It use cases teaching, visualization, sampling. It used for benchmarking. So if you want to benchmark, if you want to test the scalability, so what we want is scalability test or benchmarking. For these kind of data, we require this challenging data set. That is a comparison between iris and fetch code. Now, if I talk about iris and if I talk about the implication of different kernels, so if you see this particular program, let us go to that program if it is giving the result. So let's say it is still running. I think it is still running. So let us go for program. So we are having this Jupyter notebook, which is named as demo iris other data Jupyter notebook. So what I will be doing here in this case, I take instead of 4 features, I did the classification based on sepal width and sepal length. Why I'm doing this? Because I know the data is small and my objective J is to reduce or to minimize number of features in classification without compromising classification accuracy. So I apply linear kernel, I'll apply polynomial kernel, I apply radial basis kernel, I apply sigmoid kernel, and I find almost 73% of accuracy I'm getting. Now, what I did, I changed the data to the breast cancer data set. Now, this data set is more complex. And now, if you only take, certain like two textures and radius, what I will be getting over here is less number of features. Let's say this is 0.89. This is 0.89 with less number of features. Now, if I take 5 features for the classification, so I will be getting 91%. So you just see the accuracy of linear kernel. So linear kernel, analysis of linear kernel. So what I will do, I will put an analysis over here. So here accuracy, number of features selected 2, number of features selected 5, and number of features selected all. If you plot the accuracy, so it is 89%, then it is 91%, and then it is 95%. So increase in the number of features used for classification, the accuracy is actually increasing. But in some cases, kernels are not suitable for it. Here in this case, the accuracy is substantially reduced. Accuracy is substantially reduced over here. Here in this case also, there is no, further difference. But in case of linear kernel, if you calculate the accuracy, you will be finding that you can have, a high classification ratio with the number of features increased. So that's, analysis of breast cancer data be done. Now, let us check out this diabetes data set. Let me check whether the computer is able to run this program. I don't think. So I will show you the HTML file. Now, let me show you this. Now, this is the original program which I was running. So here in this case, if you can see here 2, this 2 means that I'm only taking 2 features in account. So when I was taking 2 features in account and particular 1 versus 1 configuration is used, I would be having 73% of the accuracy. Now then what I did, I changed the configuration to OVR 1 versus rest. So I will be getting same accuracy 73. That means if you are changing the configuration of HVM 1 versus 1 to 1 versus all, in this particular case on the iris dataset, the accuracy of the framework is not actually same. Now, but you just take this example. When I took the example of breast cancer dataset and I tried to run with linear RBF polynomial and sigmoidal functions, I would be getting, I was getting, the values which are shown. Now, if you can see that data set of load iris, if I include all the features, I would be getting the accuracy 100% in this particular case. Because instead of 2 features, in previous example, I was having all the features in account, and that's why this linear polynomial and radial basis kernel are giving 100% of accuracy. Now, what I did next is I used dataset load breast cancer, and then I calculate the accuracy to 95%, 91%, 58%, and 46% for these implementation with 1 versus 1, with 1 versus 1 polynomial. Now, when I change 1 versus remaining, then also I will be getting, almost the same result. So I can see that on, less complex data set, this 1 versus 1 and 1 versus rest examples are actually not visible in this particular case. Now, let us see how this diabetes data set is actually doing. So let me click. Now, when I was doing analysis on diabetes data set, so what we are having, 767 samples, the pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, database prediction function, age, and outcome. So this 10, it's a, a binary, simple problem of, two class classification. I did some scale. I trained the SVM model and I apply different, linear RBF polynomial kernel with 1 versus 1. So I got, accuracy 80%, 75%, 73%, and 733%. So likewise, if you can see that in some cases, the accuracy was compromised. But in our cases, in this diabetes case, where we are having, multiple features. So if you can see the pregnancy, it's a feature. Glucose level, it's a feature. BMI is a feature. Diabetes pedigree function is a feature. Insulin is a feature. And skin thickness is a feature, which is contributing to contributing to class 1, that means diabetic, or class 0, healthy. So for both these two implementation, I would be getting these two diabetes cases. Now, comparative analysis of different kernels. So for this linear kernel, it's giving me 80% accuracy. Here 75, 74, 74. So this is the comparative analysis of different kernels. Now, let us take one case study. Madam, can we take one case study?
Sir.
Yeah.
Okay, sir.
So, yes, I will be taking this case study, but I want to check whether the program, still it is struggling. No, but yes, one output I'm having over here, that this second cell has run and it is giving the output 38395768. Like this, it is giving the class, but this third one is still running. So what I will do, I will try to run it. Meanwhile, I will try to, showcase this class, this real world problem with you. Now, what I'm intent to tell you in this presentation, that with the help of these benchmarking data set, the help of these data set, can you see this slide?
Yes, sir.
Okay, I heard something, that's why I stopped. I thought there was some question related to this. So this case study I discussed with, a few months back at PDA College of Engineering, where this particular project which I was discussing to you, the two class classification, what we did in the real life problem. So with this case study, I will be discussing a few facts and preliminaries related to air quality index prediction, air quality prediction. Then we will be discussing air quality indexing system. Then a proposal of the cumulative index. So if you want to do some research and classification, so this I suppose that you are faculty member and you need to publish some good papers, or you are a student, PhD student, maybe attending this particular program, MTech student. So what you need to do, you are having a certain set of Python uh, libraries. So what you do in this particular case, the major problem is that with this classification research, you can go into two directions. The first direction is either you can formulate some boundary based on mathematical adaptation. This is the first research direction. Second, with the existing libraries. And the second part is you can do something in pre-processing of the data, oblique application of signal processing. And the third part is evaluation metrics. So this is the research landscape we can have for the Python problem. So now this case study falls in this particular first part, where I formulate a boundary based on some mathematical adoption. So for that, what I need an existing air quality indexing system by which I can, formulate this particular boundary. So what we did here in this case, let's talk about air. So it says that air is all around us. So we need to take care of it. We need to take care of it, and we should develop, certain habits and certain government policies. We should enforce some kind of government policies and some kind of civic sense, so that air all around us is, an ambient air can be, potable water, and it is, it is free from, pollutants. So air is one of the important factors responsible for life in living organism. So what we don't need that any contamination in the air, like human life, plant life, animal life, is actually basic cause of pollution, and it sometimes poses a threat or a challenge to the human life. So what make it contaminated? So primary pollutants, secondary pollutants are there. So some of them are in chemical form, as they are released from the source directly, and some of them are actually a part of chemical reaction of two or more pollutants. Now, why should we worry about pollution? So we should be worried about pollution because air pollution affects every one of us. Air pollution can cause health problems, and in extreme cases, even death. Also, death threat is also there. Air pollution reduces crop, can damage the soil, and can have a significant economic loss. So cause of air pollution is storms, volcano eruption, pollination, forest fire. Some human-made air pollution is also there, fuel consumption, air emission from vehicles, gaseous waste from the industry. Primary and secondary pollutants are like CO2, CO, NO2. These are primary pollutants, and after some chemical process, we would be having secondary pollutants like hydrocarbon, smog, SO3, HNO3, H2SO4, H2O2, NO3, and SO4 sulfates and sulfur dioxides, and all these chemical are secondary pollutants. If you talk about major pollutants, so SO2, NO2, these are, quite hazardous for the human, because if we are exposed to high level of SO2, it may cause bronchitis, heart issues, and respiratory illness and asthma. Similar thing is related to, NO2 when we are exposed to this. So it is having harmful effect on even on buildings, bridges, and aquatic life. So it is an outcome of oxidation of nitrogen monoxide. So NO2 is, the major source of NO2 is, agriculture process. Likewise, we are having two very dangerous particles which are related to suspended particulate matter (SPM) and respirable suspended particulate matter RSPM, जिसको हम PM10 भी कहते हैं. So these are small microns, in very small particles, and we can inhale it. So while inhaling all these SPM and RSPM, it can cause to cardiovascular disease, it can cause to respiratory issues, even in later stage it can cause lung cancer also. So these are solid particles and dust particles, industrial waste and conventions. Now, if you talk about the air quality index, so certain air quality standards or ambient air quality standards are having this SO2, NO2, SPM, and RSPM. So, if you want to read the review of this particular air quality index system, this particular paper is quite good, and you will be able to understand what is the air quality index system. If you talk about different air quality index, so there are multiple index. So I told you that I did research landscape one. That means somehow I will try to find shortcomings in existing mathematics. So I found that pollution index, it doesn't include concentration of all pollutants in competition. That is a shortcoming of this. Air quality depreciation index, computationally complex. Integral air pollution index, it is ambiguous in nature and less sensitive to pollutant concentration. Aggregate air quality index based on 5 pollutant at a time, so computationally complex. Fuzzy air quality index suffered from the pitfall associated with fuzzy logic. So with fuzzy logic, what is the problem? So there is no crisp mathematical boundary between input and output variable. So that's why the index is based on fuzzy logic. So it is suffered from the same pitfall. So when we talk about air quality indices, so I found that this AQI was 2.5, like this I calculated, and 255.28, 255.28, 160.94, 255.28. So here we are having three same values, but the concentration is different. So 2.5, 8.75, and it is not varying. So here 257, PM10, 48. Here you see 271, 12.5, but the value of this index is same. That means if the concentration of PM10 and PM2.5 is actually changing, but this particular indicator is not very responsive towards the change in the concentration. Likewise, I found that this AAQI is also, not very much changing, and the Euclidean distance is not very high. But on the other hand, if you talk about this cumulative index is actually 851, 455, 702, and 931. That means this particular index is having large Euclidean distance and easily separable with the help of linear classifier. So if you see the AAQI calculations which are shown over here, now with this we can propose, current indexing system, we can propose a cumulative index. The index is computationally efficient. It doesn't suffer with the eclipsing ambiguity, and it is easy to understand and follow national ambient air quality standards. Now, here we develop 4 classes. So R1, R2, R3, R4, and R5 are 5 classes. And this AQI pollutant is referred to these classes. So if AQI SO2 belongs to this R1, that means the concentration of SO2 for this particular part is healthy. If AQI of PM10 is falling in this category, that says that the concentration is high, and it is referred to dangerous concentration. Now, what we did over here, that we define the cumulative index. So here, again, proposal of a new index for increasing linear separatability. So this is case 1, where AQISO2 belongs to R1, this belongs to R1, this belongs to R2, this belongs to R3. So accordingly, what I did here, mean value, here mean value, here mean value, here mean value, and here average of all four. So this become cumulative index. Now, what we did again, that we change R1, R1, R3, and R2. Then we change R3 and R4. So this belonging to this R1, R2, R3, and R4, and subsequent mathematical implementation in case 1, case 2, and case 3, based on some practical experience. So if you are dealing with this kind of variables, you will be having, this mathematical. And this is my paper, which I have defined, where I defined this particular index. Now, what we did, we created a synthetic data set. So here we are having 354, 354 here, 354, and the value of CI is like this. So if you can see the Euclidean distance, now if the CI value of CI is greater than 700, we can say that the air quality is poor. Now, what we did, we created a supervised learning on the basis of this, and we choose mean as standard value, and we develop some probability distribution, and we took the data of Madhya Pradesh, Delhi, West Bengal, and a synthetic data set for the Gujarat location, and we find that the data is sparse. And we can have this SVM for the classification purpose. Now here, if you see the regression agents, then what you will be having, we are having input vectors, then we are having support vectors, then we are having kernels, then we have bias, and then Y. So if I want to establish the equation, so this W1 X1 plus B. So if you scalable it, so this Y1, Y2, Y3 here, and this matrix will be, X vector will be there, W11, W1n, Wn1, Wnn, and this vector matrix will be there. Then this X1 to Xn, and this B1 to Bn. This will be there. So this is the mathematical implication of this. Now, these are the N activities, and we have discussed this earlier. So what we did here, that we apply, some tuning algorithm for training, this hyperparameter tuning. So what we did in SVM, we are having two parameters which are critical. So shape parameters and kernel parameters, and choice of kernels also. So choice of kernel. So we choose one very good kernel, which is RBF kernel for this particular problem. But the shape factors and the this kernel factor we took in account, and we apply Gray Wolf optimization algorithm for tuning this. So compare the result, build the model, training the result. Then different models are there according to the optimization. Then training the result and the test result, and they compare the result. So this is how we develop this. Now, for the verification of the results at the real location, we took, the data of Govindpura. We took the data of, Nizamuddin, Molali, Kolkata. And then we discuss this particular part of Madhya Pradesh, quality of the Madhya Pradesh. So here, if you can see the label, so this is 1, and the remaining, which is negative part, described by the negative one, that shows that the air quality is actually compromised. So greater than 800, we say the air quality is not quite good, because if you see here, 235, 257, 252, here the air quality is not, here PM10 is not very high, but remaining part like PM10, PM2.5, and AQI related to PM2.5 and NO2 is very high. So the cumulative index is high. So it says so. This AQI is based on measurements, and this is based on cloud computing. So more data is coming into the framework, and the fashion which they are dealing is quite following each other. So both of the data is following each other. So if you see both of the data, so the data is following each other, and it requires less number of air pollution centers. So air pollution centers, APCs, can be reduced, and we can use machine learning with the help of the air concentrator or the phasor measurement units, which you can employ near to the pollutant areas, and you will be finding that this AQI, AQI and CI are following each other. So with the help of support vector machine, I could classify the data into positive and negative class. Now, with this, we can have the conclusion which we have started with the first slide, that somehow if I challenge the mathematical framework of a classification boundary, I will be able to develop a new classification engine. And later on, with the application of this classification engine, we can find that we can reduce the complexity of the system. Also, we can use linear separators, which are less complex. Also, we can reduce the dependability on an existing physical infrastructure, which can be employed or deployed at different part of cities for monitoring. And with the less number of monitoring units, we can also having the less analyzer, as well as the economic benefits are also associated with this type of applications. Now, so I think with this, I can end with session 1. And madam, can we take 5-minute break?
Okay, sir.
Just I will write 2 questions. So you need to do this question 1. So I asked the question 1 that give the example of imbalance. Question 2, give an example of a real problem pertaining to 2-class classification. So you solve these 2, and madam will be evaluating, and I will take 5-minute break. After 5 minutes, we will be starting. So can you all see my slide? Can you see my slide?
Yes, sir.
Okay. Madam, can we start? Because I have not done with this topic. So can we start with this topic and then session 2 topic we can continue? Is it possible, or I should hold this?
Whatever you say, sir.
No, I want to know the protocol, because if
Ah,
you'll say I will be able to discuss more, one more
ah,
case study is there in this, 2 class classification, I can take it. But if you say
okay.
that I have to do with, that MATLAB, then I will
Hmm.
be dealing with that MATLAB. So as per your choice.
Sir, that session 2, then when will be starting, sir? How much time it may need for to end up
Madam,
this?
at least I will take 15 minutes more with this particular topic.
Okay, sir.
Is
Then
it
you
okay?
finish up this one, sir. Then we will start with the second one.
Because that is
Hmm.
a particular case study of a
Hmm.
two-class classification. So all the
Okay.
participants who are listening to me,
Yeah.
you need to submit the answers of these 2 questions to the madam, and
These
accordingly,
are they are posting it in the chat boxes, sir.
okay, chat box, madam, you will
Ah,
would you
I'm just
okay, you evaluate, madam, and
ah,
maybe they can submit separate assignments.
okay.
You
Later on.
allot, later on they
Okay,
can
sir.
submit.
I will collect, sir. Afterwards, I'll collect.
So this is assignment related to this particular class. Okay.
Okay. Okay, sir. I'll collect it, sir.
Let me write, madam. Let me
In my
write.
feedback form, I'll add these 2 questions and then I'll ask, sir.
And more, with the discussion,
Okay.
more, problems will be. So what you will do, you make one PDF of this and you
Hmm.
upload to the madam's, whatever feedback madam is sharing with you, you have to upload this PDF in that feedback form. So this is assignment I'm giving. Now, apart from, my this particular presentation, what I'm intent to do is that I will be trying to develop a strategy in an energy market where you can you can find the interval of prediction. So we are having a variable. So this variable is what? Let's say this variable is electricity price or price of petrol, and you want to do bidding. You want to bid. So if you have the anticipation that this particular bid is high and this particular bid is low, so this makes a classification problem between high bid and low bid. So this forecasting becomes quite easy when you try to develop this forecasting mechanism between high bid and low bid. So for this, I have taken one paper, one research paper, spam detection and medical diagnostic. Shall I start?
Okay, sir.
Yeah, madam. Okay. Shivappa, yes, I am starting. So I will discuss this particular paper which related to midterm electricity market clearing price forecasting. So what they're doing in this research, that they are developing a support vector machine over here. This is the development of support vector machine where it is subjected to the class, that a certain class is there. So if it is related to, if it belongs to class 1, it belongs to class 2. it will evaluate this. So we are having, two class classification over there. There are certain metrics, which is error metrics, which is used for evaluation. This is also error used for evaluation of the metrics. Now, this is also a matrix which says number of correctly predicted vectors in class A, number of predicted vector in class A. So correctly predicted and total predicted vector. Now, multiple SVM based midterm electricity market. So what they did actually, they actually employ SVM for different price band. So this price band 1, price band 2, price band 3. So for separating the data into these 3 bands, what they require? They require SVM and they require multi-class SVM. Multi-class support vector machine. So here in this part, if you see the data selection process, so the potential input data, actually they are having right here. The input is going in this forecasting model with the hourly demand. Does the added input data improve the forecasting accuracy? If it is yes, new data is taken as input. Is this the last possible combination of the potential? If it is yes, cross validation and the program is selection is completed. But if you are having no data, then again it is going to select a new data. If it over here, then it is move on the next combination and move on to next input data. So likewise, they are construction of input feature matrix on the basis of accuracy. Now, if I want to tell you that how they are the problems associated with utilizing a single SVM in different price zone analysis. So this is what this problem says, that you need to find the solution of this problem through 1 versus 1 and 1 versus rest configurations. So electricity, it says it is a unique commodity. It cannot be economically stored in large quantity. So what we need to do? We need to utilize it. So for utilizing it, what they did, so table 1, let's see table 1. So the trade-off between SC and MAE of the price zone and multiple SVM can be, find out. So 100%, 93, 80, M74, 72.9, and the mean absolute error related to this is like this. So what is SCA over here? So this SCA is what? This SCA is actually the different time zone. So according to the simulation result, separating the electricity MCP into 4 price zone. So first is the electricity MCP into 2 peak and non-peak, low and medium high, 5 low, medium, high, low, peak, and high peak. So likewise, they they segregate the whole data into 3 parts. So once they're done, what they do, they define the classification boundaries. So the classification boundaries, like it is coming from this. So MCP is less than mean minus SD. Then medium, so mu minus this, MCP mu plus 0.5. Likewise, this is class 1. Likewise, this is class 4. So what happened to this? They define different mathematical boundaries to segregate the data into 4 classes. So what they did here, that they did the, with single SVM, they predict, low, medium, high, peak, and total system demand. So what they get, different result like MAP 35, 6.1, 7.2, 14.5, 11.7. And if you see the other implementation, multiple, SVM. So what they have done over here in this case, that this is the data, this is the input data, price data is coming over here, the electricity price data. Then what they did, they classify. So this first classification is peak. So all the peak values are coming in this, and the rest values are going in this. Then high price SVM is coming in this. Medium price SVM is doing classification. Low price SVM is doing forecasting for this. So this particular SVM, this is set for forecasting of peak price only. That means the data which is employed in it and the data which is used for testing, it is related to peak price. Likewise, in this high price SVM, the data which is set for forecasting, this is set for high price only. And this is set for medium price, and this is set for low price. And let's evaluate the results of this. So when we evaluated, let's see MAP values of this. MAPE value, if you see MAPE value, 35.9. In case of multiple SVM, 23.93. 6.15, 5.6. 7.2, 9.55. 14.5, 7.7. 11 and 10. So instead of single and multiple SVM, what we find that single SVM regression, the accuracy is compromised. So in multiple SVM, what we did, we classify different classes on the basis of mean and standard deviation, and then we develop classifiers, and then we develop a regression. So after developing this regression, what we found that a better matching of data. So the variable would be able to anticipate, or the framework is able to anticipate here in this case multiple SVM framework is able to anticipate the data or the interrelation between input and output data. So this is very important part which I would like to tell you, that in case of multiple SVM, this particular framework, which is bounded in a closed envelope. So this multiple SVM, that means classification, class identification, and then regression. So this has been done very beautiful in this particular paper. So if I want to summarize the application, over here, and I will be sharing this paper to you. So summary of this paper is what they did. They are trying to there is a pool of data, so they are having price. So what they're employing? They're employing one SVM, single SVM for forecasting. So this forecasting is done on the basis of regression. In second approach, what they did, they apply SVM, multiple SVM for definition of high, peak, medium, and low. And then they forecast. Here, the system is scalability of the system is increased. System is more scalable and enabled with the big data, but the accuracy of the system is accuracy of the forecast is increased. One more thing I want to tell you that the accuracy of forecast is inversely proportional to span. So here in this case, what we are developing day ahead forecast. That means the forecast which is a few hours horizon, or maybe if I'm not mistaken, the same people, we are doing medium term forecast. That means for some of the month we are doing. So this is the crux of this paper, that we are doing the price forecasting. We develop one SVM, there we develop three SVM. We develop the classification and the forecast accuracy. The data is actually high with this. Now, similar Python framework you can develop. So let me see over here if I can if I can show you the Python framework for the diabetes dataset. So let me show you the diabetes dataset to you, and then we will be discussing our next part, more programs and the diabetes dataset. Now, when you see this particular data set, which is related to diabetes, so you are having one data which is, data related to pregnancy, data related to glucose level, data related to blood pressure, skin thickness, insulation, body mass index, diabetes, some index is there, some function, age, and the outcome. So the outcome is either this person is diabetic or not. So here in this case, when you talk about this particular part, this particular implementation of multi-class SVM, here you can see that the SVM, the electricity price is falling into which category? Higher category, lower category, or intermediate category. So accordingly, you will decide the level. I have downloaded one more data set which is related to frog data set. If you can see my screen, I will show you this. This is one more data set, very large data set, which is having numerical values here. So these all are the related values, and the last three columns are categorical variables which are depicting the family, genus, and species related to information related to this. So different type of information. So this is one, and then this is second type, then this is third type, fourth type, and multiple species are there, like 10 species, 10 different, 10, 12 different are there. So it is a big database. Likewise, according to this problem, and according to this implementation, you can always segregate this particular electricity price into multiple zones. So with this, I come to end of this particular part, which is related to Python implementation. Now I will be delivering session 2, which is related to application and the development of MATLAB programming. And let us see how far we can go with this. Madam, shall we start with session 2?
Okay, sir.
Okay. So it says hands-on अब मैं इस पाइथन वाले मॉड्यूल को बंद करूंगा एंड आई विल बी शेयरिंग सम ऑफ द प्रोग्राम्स विद यू, है ना?
Okay,
इज इट
sir.
ओके?
Okay.
Okay, madam, just a minute, madam. So I'm putting it off. This one, this one, this one, and this is the annotated paper. So I'm saving it for you. So later on, you can share it with annotate this PDF to participants. And I am closing this kernel. Now it is closed. Uh, hmm, this Excel also I'm closing. So I know this particular part related to vector operation, probability distribution, and data visualization is quite basic. And to the best of my knowledge, related to the participants of this FDP, what we will try to do is that we try to solve, all these things, and we try to apply all these, vector operation and probability distribution on a certain program. So let us see how they can do with it. So all these, attributes like vector operation, probability distribution, and data visualization techniques, we can study in optimization algorithm. So this optimization or engineering optimization, it says that it is related to, it is subjected to objective function, which represent a quantitative measurements that have to be maximized or minimized. Just a minute. So it represent a quantitative measurements that need to be maximized or minimized. So we are having two objectives, like if I want to maximize or I want to minimize. So for any optimization algorithm, optimization, we are having two options. Maximize or minimize. So I want to maximize the efficiency. I want to maximize my profit. I want to maximize positive culture, happiness, social welfare. I want to minimize worry. I want to minimize loss. I want to minimize, maybe deficit, minimize, negative interactions or security threats. So all these can be objectives. So this problem comes with the inequality and the constants. So when we talk about inequalities, like x is between 5 and 4. So here you require, for formulating this, you require what? You require vector operations. Now, if you see this particular landscape, so this is having, this part is minima, and here in this case, this part becomes maximum, because in this landscape, the value of this point, the value associated with this point is maximum for this function, and here in this case, it is minimum for this function. So for the representation of any optimization problem, we require these vector operations, and sometimes we employ different probability distribution for showcasing different data distribution for MATLAB implementation. So in optimization, what we require, we deal with algorithm, and we deal with the nature inspired algorithm. So some nature inspired algorithms are there, and these implementation of these nature inspired algorithms are actually can be done with the help of these matrix operation. So if you see the MATLAB window over there, so if I write A is equal to 1, 2, 3, and if you put over here, so it becomes a linear matrix. So if I want to write A is equal to 1, 2, and 3, and then semicolon 2, 3, and 4, then semicolon 3, 4, then semicolon 3, 4, 5, and 6, and then I close the bracket, it becomes a matrix. Okay, so this is how we developed search agent search matrix. So let us take one very beautiful example of algorithm which is known as marine predator algorithm. So let me show you code of this marine predator algorithm, MP algorithm. Just see the code of this particular algorithm, MP algorithm. So this was originally coined by some of the Iranian scientists. So here, when you talk about MATLAB, so let me take printout of this and let me save as PDF. Let me do it. So if I can save it, no, I cannot save it. So let me copy it and Control A, Control C, and Word. And I will tell you how this algorithm is actually working, and how the probability distribution functions are actually uh, creating in this particular algorithm. So it's a special kind of case study of this algorithm is over here, and Control A, and let's remove space, and let's reduce space to 1. And let me save this particular save as save as marine predator algorithm source code. So if it is coming here, let me see MPA code. It is okay. Source code, save as. Just let me save it, and then we'll start. And then I will be able to demonstrate how this algorithm is working and how the probability distribution and other statistical techniques can be utilized for this. So if you see this particular algorithm, so this particular part is nothing but the introduction of the programmers. And authors. So this coming with the percentage sign, that means these are code, not codes. It will be considered as comments. Now, when we go in this particular algorithm further, what it says the function. So this function can be called in program having input this search agent number n, maximum iteration, lower bound, upper bound, dimension, FOBJ, FHD. So all these things are input. So the name of algorithm is MPA, and it is consisting of some inputs which you need to be fed. So these inputs should be known to us. So when you are giving these inputs into the algorithm, it will provide you what? It will provide you this variable top predator fit. It will provide you top predator position, and then it will provide you what? Convergence curve. So all these things, if you run the program with the proper set of input, you will be getting these output variables. So these all are output variables. Output or outcome of the program. Output of the program. Not variable, but output of the program. Now here in this case, what they are doing, this algorithm is based on predatory behavior of marines. Like there is one predator and it is hunting for food. So here what they are doing, they are creating a predator matrix. So for understanding the behavior of predators, let us have this video which will tell you that what are the predators, what do you mean by the predators. Can you see this video?
The predator's powerful nature, piercing looks, and spine-tingling howls continue to inspire both adoration and controversy around the world. There are two major species of wolves. One species is the Ethiopian wolf, or Canis samensis. Only about 500 of these wolves exist, and they inhabit the mountains of Ethiopia. The majority of the world's wolves belong to the species called gray wolf, or Canis lupus, numbering up to around 250,000 and including up to about 40 subspecies. Gray wolves are scattered across the northern hemisphere. Wolves are highly social creatures and operate as a group, or pack. Often comprised of 6 to 10 wolves, packs are cohesive units that hunt and live together. Within the packs, each wolf has a unique personality. To maintain order among them, a male and a female dominate the pack as alphas. They establish a strict hierarchy and are the only wolves in the pack to breed. Each wolf's howl is unique. Much like fingerprints on humans, howls are distinct to each wolf. Characteristics like pitch and amplitude of these vocalizations help signify which wolves create certain howls. These vocalizations allow wolves to communicate with other wolves. They may howl to indicate their location to pack members, deer, elk, and bison populations, prey normally hunted by wolves. Without their usual prey, wolves then resorted to hunting livestock. 1930s, wolves were conservation policies, efforts to educate the public, and programs that reintroduced wolves into the wild were enacted, aiding the comeback of these legendary creatures.
So where we were talking about the predator and the searching of food mechanism. So here, in this case, if we talk about this algorithm, so the predator is here in the case of wolf, what we define a hierarchy between alpha, beta wolves, and other. So alpha was leader. So the philosophy is follow the leader. This was the philosophy of the algorithm. So here in this case, this is again a function which produce random number or random positions, random numbers of the wolf. Like if you are having 50 wolves and the search agents number and the dimension of problem is 4 and the upper bound and lower bound is defined that x1, x2, x4, this should be between 20 and 10. So what they will do, this particular code will actually develop a matrix of 50 by 4 and all the elements between 20 and 20. So here you need to put the matrix operation and you need to create, a matrix of this. Now, here in this case, what is happening, we start the iteration count to 0. So iteration count is equal to 0. Then this is some parameter which is specified for the algorithm. And this is also a probability which is specified as a fixed switch for the algorithm implementation. So it says top predator. So here in this case, what happening here in this case, they are actually reassuring that no variable go out of bound. So that is the code that if set a flag if it is greater than UB, set a flag if it is less than UB, and then LB. So no, all the solution should be between upper bound and lower bound. So this particular code is taking care of that. Now, what is happening over here? Here we are evaluating the fitness. Evaluation of the fitness. So fitness function is evaluated. So if you want to minimize and certain set of wolves are giving very low values, so we consider it top predator. Now, and positions associated to those are saved in memory. So the position and the configuration of the predator is solved in this memory. Now, what they are doing, let us talk about this particular part where you are having levy distribution. So this actually algorithm behave that whole hunt process is divided into 3 parts. So in phase 1, what happened? Predator moves fast or predator moves slow and prey moves fast. In second phase, both are equal, velocity of prey and velocity of predator are equal. But in phase 3, velocity of predator is higher than velocity of prey, hence the hunt is completed. So the objective is to reach global minima, and this is what we call, here we call that the algorithm is converge. So the convergence is guaranteed with these two phases. Now to simulate these phase 1, these phase 2, and this phase 3, what is happening for simulating these phase 1, phase 2? What we require? We require vectors which are moving fast, which are moving slow, which are moving with different. So here, this algorithm, why I chose this algorithm? Because it uses Levy random number vector. So Levy distribution it is using, and Brownian random number vector it is using. So this RL and RB, different with different probability distribution. What we require, we divide this phase. So phase 1 is related to 1/3 of iteration. Phase 2 is related to between 2/3 of iteration, and phase 3 between 1/3 and 2/3, and phase 3 is greater than 2/3 iteration up to final. So in phase 2, what they are using this particular distribution like RB, this RB, and this P and R values is R is random number. Again, in phase 2, what they are doing, this is using RB. They are using RB, one CF factor, then RB, then again they are using R, then again they are using R. Now in phase 3, now in phase 2, we are having two explanations. So one is RL. In phase 2, what they are doing, they are using both RL, Levy distribution, and Brownian distribution. But in phase 3, what they are doing, in phase 3, they are using Levy distribution. So in this case, this RL and RB implementation says that both of the predator and prey are actually running, or the velocity of both of these entities are equal. Now here in this case, what they are doing, they are following that expression also, and these are some random number, these are some random numbers, this is the allied pollution matrix, and this is the difference. So some random numbers multiply with the matrix, and the again both of these matrix which we have implemented from the initialization. Now after implementation of this, let me show it just a minute. After implementation of this, what we do, we apply a probability switch here. So if random number is greater than this FAD, so fish aggregating device, or this is some kind of variable. So if it is less than this, they will apply this equation, else they will apply this explanation. Now all these things are actually accumulated. If all the implementation is done, we will run the iteration, we'll append the iteration with 1, and we save the top predator fit. Now let me show you this particular implementation with very simple example. So what I want to do, I want to tell you one thing, that right now I have discussed the code which is MPA. That means an algorithm code. So the algorithm code written in function, it has certain inputs and it provides output. And in between, the algorithmic structure, which is consists of different probability distributions and their implementation for position update, then initialization through random numbers, then some decision-making loops, and then memory saving. Now, there is a main program which calls this. So this main program is having what? Initial parameters, calling of MPA, a syntax which is related to calling, and then representation of results. Also, it provide input. It provide input to the program. So this input is based on some auxiliary units. Some of the auxiliary units which we can have, some of the auxiliary unit we will be having. Let's say, what are these auxiliary units? So auxiliary programs. Which are these auxiliary programs? First program is function details. So all the function benchmarks, all the things are evaluated and related to this. All the information, all the info related to parameters. Search agent, lower bound, upper bound. And third, you may say total number of iteration. So this is how the algorithm is actually look like. And now I will try to implement some of the algorithms, some of the programs through this particular implementation. And let me show simple implementation of MPA. Just bear with me for 2 minutes, and I will be able to locate this MPA program for so in this case. Let me show you one simple implementation, and then we'll see the algorithmic part. So this MPA program, uh, whatever I was telling you related to this implementation of this MPA. So this MPA program is having three major part. First part is the main function calling, where you need to supply the input. And then we will be having the part which is related to definition of the function. And then we will be having the part of, let's say, the main program. So in this main program, if you can see, the maximum iteration is 2000. The functions which we are using for the implementation is CC17 function dataset. There are function ID, then get function details, and then we will be having one loop which is calculating the total time of implementation for different algorithms. So I've implemented many algorithms. So let us see. Let us make it very short, like for 20 iteration. Let me draw this. Let me run this program. So let me run this program. So C17 function. Let's say let's open this main2 program. If we can run this. So CC20 functions. So just a minute. So just see, the program is running for 30 iteration. So when you are running it for 30 iteration, you will be seeing that results will be coming. And let's say what results are coming. So we are having, we are having one convergence curve, which is coming for this particular implementation, and the analysis is shown that some of the algorithms are having, very steep downward trend, and it is able to, let's say, it is able to minimize this, minimize the function very efficiently. So if you see the different data characteristics, so let me write box plot. Let me implement this box plot analysis. So this box plot analysis, what it will show, let us see. So we are having this particular part. So time implemented for 30 iterations. Let me put this. So if you run this box plot, you will be able to see that this is the box plot which is run for 2 iteration, and 30 times we are actually developing this particular algorithm for the comparison. So let me show you one more simple program, like one very simple program of gray wolf optimization algorithm, where we were dealing with the application of this gray wolf optimization for simple function f1. So let's say I'm trying to run this particular program. So this is the main program. So what I am doing, I have provided some input, certain inputs like search agent is equal to 30, number of function name is f1, and maximum iteration is equal to 500. So this f1 is what? F1 is a type function which shows certain data distribution characteristics. So let us see what is f1. F1 is what? So F1 says this F1 is what? I is equal to 1 to I is equal to 30, and this is xi square. So this F1 become x1 square plus x2 square and up to x30 square. So I want to minimize. So I know if all x1 is equal to x2 is equal to x30, it should be equal to 0. Then the value of f1 is equal to 0. So the minimum number of the minimum value of this f1 is equal to 0. So let's see what this function is telling us. So this function f1, we are trying to search the x between -100 and +100, and these 30 variables are there. And accordingly, if you see the definition of this function, so definition of this function is, here you can see function f1 is sum of x square. So here I have written sum of x square. This is a very well-known function which is known as sphere function. Now, let us run this particular program for sphere function. So what I am doing here, number of search agent is equal to 30, number of maximum iteration is equal to 50, 500, and I reduce it to I is equal to 20. And let's clear the workspace. Clear. Let's clear the workspace. So clear. Let me run this program and we'll see how we can analyze this program, this particular program. So this program is running. So maybe 20 times it will run. Now 20 times it is running, and it will give us, like, let me clear the screen. Now we actually compared 2 algorithms in this particular program. So in this particular program, one is GW and another is a modification in the GW. So somehow I tried to implement some of the modification in the GW. So now see how this modification is actually contributing in the performance of the algorithm. So over here, if you can see the total score. So let me define one matrix X, and I put this variable into this metric first, and the second matrix, which is modified gray wolf optimization, is, and let me analyze both of these variables. So Uh, so now, if you can see, the x is a variable which is in one way it is having some of the values, but in another part which is modified gray wolf optimization, it is showing zero value. So first thing we can do, we can plot the box plot, and let us plot the box plot for it. So when you see the box plot, and if it is coming in such a manner, you will be able to see that one box plot is like this, and one box plot is like this. So this particular part is IQR, interquartile range. So for this particular algorithm GW, IQR is high, box plot is thick, and here in this case, it is a line. That means box plot is super narrow. So this is for algo 1, this is for algo 2. So if you do the statistical analysis, you will say that this particular algo 2 is more precise, because all 20 run datas are falling in a very thick, very thin range. But here in this case, we are having, the quadrant value is there, and there may be some outliers also. But here in this case, we are having only one line. So you just see this box plot. So this is mean value of the 20 iterations, and this is very super narrow. So one thing, you can do statistical analysis with this. Also, if I take mean value of x, like mean value of 20 iterations, so one is 0.64 into 10 to the power minus 27, another one is 0. So like this, you can do the analysis. And let us take one more, probability analysis, which is known as p-value analysis. So rank sum test. Rank sum between this and rank sum between this. So when you do it, it should come less than 0.05. So it is coming 10 to the power minus 0.9. That means if you again repeating this particular experiment, you will be getting the same result. Let us check whether we are getting the same results or not. So I am clearing all the data, CLC, and clear. And I will be running this algorithm again. So I run this algorithm again. It is a comparative analysis of marine predator and the advanced version of the marine predator. Okay, it is run. It has run, completed the run. Now again, I CLC. Now I again create the matrix X is equal to this. Now I again calculate box plot. So let's see how box plot is coming. Just see, have you observed the change? Now the box plot, the size of this box plot is more. So the algorithm is, giving different result at different time. Now let us check whether it is statistically significant or not. So what we do, we checked it again, and again the p-values are less than 0.09. So I will come to the presentation of where we are about this optimization. So the classification of optimization is actually between meta-heuristic and heuristic. So the meta-heuristic is actually divided into three parts. One is evolutionary based algorithm, second is trajectory based algorithm, and third one is swarm based algorithm. Then we come to trajectory-based algorithm, evolutionary algorithm, and swarm-based algorithm. All the classification. You can click picture of this particular part because I have I have dig the literature in such a manner that I could find this classification into that was deeply buried in some of the classical research papers. So you can take a picture of it and you can implement it. And later on, I will share these PPTs also. So this optimization says that with every passing iteration, it should come to near to its objective value. So if the global value is equal to 0, so with every passing iteration, it should reach to 0. So that's why it is having monotonically decreasing. So if you are using any algorithm which is intent to minimize any expression, it should reaches to 0 with every passing iteration. Suppose you are maximizing the things, then the point is that it should maximize in such a manner that with every passing iteration, the fitness function increases with the time. So when we talk about recent development related to marine predator algorithm, so it was coined in 2020, and the algorithm is based on predatory behavior of marine. It imbibes Brownian motion, Levy motion, and random motions. It incorporates a probability switch, which is for the better position update, and it is based on a fixed probability. So if you see the comparative of phase 1, phase 2, phase 3, here in this case, you can see that the iteration diversity is also actually phase 1, phase 2, phase 3 actually imbibe this. So the major research area in which the marine predator algorithms are dwelling with, that we are developing hybrid algorithm, we are updating the bridging application, we are updating in the mutation and crossover vectors, and we are developing chaotic versions. So this was the proposal which I did. I hybrid, two algorithms like sine cosine algorithm and marine predator algorithm. On the basis of a probability switch, we append the position update equations, and we find that in phase 2, it is meaningful because both of these marine predator and prey are going with the same speed. So there is a fair chance that the algorithm may stuck in the minima because both of the search agents are running in same speed. So if you provide any trigonometric function or any kind of jump in this particular phase, this will be actually enhance the algorithm performance. So the first application we did in hybrid rectifier filter design. So for this HAPF, we were having single objective function, and we need to design a filter for advanced power quality improvement problem. So what we did, we are intent to find the parameters of filter like filter gain, value of resistance and the inductance. There are certain topologies which is related to electronics engineering, so I will not discuss it over here. I will skip these results in very fast manner and some mathematical equations. But our objective is to calculating the harmonic pollution, and our objective is to minimizing this harmonic pollution so that the consumer can get a good power electricity which are free from noise, which are free from ripples, and which are free from another type of disturbances. So our objective is to minimize. So what our objective function is that we need to develop this objective function, and we need to find all these filter gain. We need to find this XC, and we need to find on the basis of that the harmonic can be mitigated. So we published this particular paper, and we try to accumulate the results. The pseudocode I will not discuss, but yes, for certain applications, you can see over here that the value of for function 1, the value of this marine predator algorithm is quite low. Mean standard deviation, minimum value, maximum value, we calculate for 20 independent runs, and we present the analysis for 23 different mathematical functions. So for the majority of the functions, MP algorithms was providing very good results. Now, then we deal with some another, mathematical problem, which was having 50 dimensions, then 100 dimensions. And we found that our algorithms is scalable and it is tried to, it is very good with the, when the number of variables are actually increased. So for dimension 100 also we tried. Did over here that we, for topology 1, topology 2, topology 3, and topology 4, we calculated, the mean, minimum, maximum standard deviation value for 20 runs, and we report the values in this. For the parallel structure also, we calculated this, and we find that MPA is having exhibit standard deviation values. We are having low standard deviation for multiple signals. That signifies that algorithm is superior as compared to other comparators. And the consistency is observed in certain algorithms. Now, the Wilcoxon-Ransom test we calculate for statistical significance. So if the value of P is less than 0.05, we say that the result will not be same. The result will be same and the algorithms are actually always having upper edge. But if it is equal to or greater than 0.05, we could say that H value is equal to 1 and the algorithm is equally competent and it is equally competent to the proposed version. So here in this case, if we calculate, if you see the H value and the P value, all these are coming same. And for MPA and between MPA and MPSCA, you will find that some of the P values are actually equal to 1 and the H value is equal to 0. That means the algorithm is compatible with the original algorithm. These are some more results which we are showing. So the p-value less than 0.05 signifies that the algorithm is performing substantially good statistically also. So apart from it, that it based on the random numbers, it also can provide some of the good results. Now here in this case, I showcase the box plot for series topology. Now this is for parallel topology, and you can see that this particular parallel topology, it will be having, very narrow, very super thin, super narrow box plots, which says that the data is actually distributed in a very fine, way. The second proposal is that I develop a chaotic version where we fuse some noise into this and we develop this comparative analysis of marine predator to chaotic algorithm. So what we did, we took COVID data and we did the classification on the basis of some attributes. Then we compared some feature selection techniques on the basis of optimization. What we did, we selected a feature space. Then we test it for the cardinality, and then we test the classification accuracy. And with every passing iteration, we change the feature. And if we get the result better, then we took that feature, combination with us, and then we tried for the next combination. So this was the objective function. So if you can see over here that MPA, MPCA, all these are actually giving better result in case of average number of feature selections, fitness values, classification, accuracy, and the convergence. The source of figure, my paper is cited into this. These are some results which are showing that the algorithm is perfect. Now we compared with different chaotic algorithms and we compared it on the basis of attribute. So you will be finding that on the basis of dimension, fitness value, and classification value, you will be able to see that maximum, minimum, mean, and standard deviation values are better analysis. So this is the pictorial depiction of this. So with this, I think I should leave some time for question and question answers. So you can always reach me on this email ID, and I'm always open to research. So if you want, you can my numbers also from Madam, and you can WhatsApp me. And these are the references. Actually, this was some part of this work is actually covered in one of my student in his PhD thesis also. So these are the reference which we have used for this particular presentation. So with this, we come to end of these two sessions. And now I will be giving you the assignment like this coding I will be sharing it to you. So this coding I will be sharing. So you need to write what are different analysis which we have discussed in this particular session. So let me write what different analysis we discussed in this session. So on a name of few, firstly we did discuss statistical attribute analysis. Secondly, we discuss box plot analysis. And thirdly, we discuss statistical significance Wilcoxon rank sum test. And lastly, we discuss convergence property analysis. So all these are related to, visualization. Visualization plus probabilistic investigation. So today's date is, I think, this I will share with Madam, and this paper also I will be sharing with Madam. So both of these I will be sharing. Is it okay? Yes. If you are having any queries, I'm open to queries. And if you want to discuss one more case study, although my my throat is choked, but we can discuss one more presentation. I think it's 9 o'clock. So do we have some queries, madam?
Any participants can ask if any doubts are there. सर
Yes,
आपको
ma'am.
टाइम कम पड़ गया.
No, ma'am. Really,
Initially,
it was informative session and very helpful session.
मैं ऐसा सोचा था कि I was thinking कि I don't know, for 3 hours I would be able to speak because today's back-to-back meeting from 9 to 4.
Yes, sir. You told that day.
Back-to-back meetings, and every meeting require lot of application of mind, और बहुत सारे एकेडमिक प्रोसीजर्स ऐसे हैं जो आपको लगातार मतलब आपको इन्वॉल्व रखते हैं, चाहे वो इट इज रिलेटेड टू एडमिशन, whether it is related to academic audit, whether it is related to any student problem. So every whole day we did this exercise, and in between I went to
एनर्जी
I
मिनिस्टर से
stopped
आपका कुछ.
I stopped all the things, and then come back for this session.
Thank you, sir. Thank you so much. That's what, sir. Today you told even you have meeting with energy minister also.
Yes.
You were stuck with that and all, na?
Yeah, madam. So it was. Thank you, Farat Anjum Khan. I can see messages now.
Hmm.
So, madam, I will share. Yes, Shankadeep. Yes,
Hello, sir. Good
please.
evening, sir.
Yeah, Shankadeep. Yes.
Am I audible, sir?
Yeah.
Okay, thank you very much, sir. Myself, Shankadev Mahato. I'm a research scholar from the University of North Bengal. First of all, sir, thank you for the very informative session.
Hmm.
First thing that, sir, I'm a non-technical background student, currently working on agriculture sector, but try to learn the technical things also because I'm from the Department of Lifelong Learning and Extension. So learning is always a fun. And thank you for the inspirational uh, entire 3 hours session, sir. So my simple question is that it might be, I don't know whether it is relevant or not because I don't know all the things. Sir, the thing is that if we uh, uh, take the SBR and
Hmm.
SBM, so for the agriculture purpose, I mean for the price forecasting, SBM or SBR, which is more relevant, sir?
SVM, I think for agriculture, in agriculture, what is the problem? Uh, you have the data related to plant disease or plant leaf disease would be there. So SVM is a very basic supervised architecture. Nowadays, if because I started with SVM because I know that some people are from non-technical background also, but because SVM was coined in 2014, 2013. So it is almost 11 years. Now we are dealing with CNNs, which can take the image data. So according to this image data, you should apply CNN, and maybe, if madam apply for the advanced FDP of ATAL, maybe we can, discuss the application of CNN for plant disease identification. So in agriculture sector, I think image related analysis, computer vision related algorithm, it should be more meaningful as compared to SV.
Okay, sir. Sir, the thing is that if we like take some of the questions like let's say for the crops, for example, like a tomato, uh, like what will be the exact price of tomatoes per kg next week? If we want to have a forecasting type of model or like question, so SBR will be more applicable, sir, or SBM? Like SBM is classification
See,
as you have already
no,
said.
no. See, the problem is uh, for forecasting, you are trying to, develop a kind of regression. That means you are having certain input variables and you are trying to, calculate some value. Huh? So for that, you
Yes, sir.
require regression. Okay, but if you want to, in my case study, I've told you that the authors applied both. Like they segregate the price into different price zones. Okay, and then first they classify, and then they implemented regression. So they find that this systematic approach is meaningful and it is giving accurate result in terms of certain accuracy indices. So the problem with the forecasting is related with the regression. So for that you need to develop a regression model, like logistic regression you
Okay.
do, or if the data is very simple, you can apply artificial neural network also.
Thank you very, sir. Thank you very much, sir.
चलो
Namaskar, sir.
ठीक है मैडम।
हेलो।
मैडम
हाँ सर।
या, या मैडम, क्या क्या अब हम शुभ रात्रि धन्यवाद कह
हाँ
सकते
सर।
हैं?
हाँ सर। हाँ सर। थैंक यू सो मच सर। थैंक कि आपने लास्ट मिनट में भी बता दिया, अच्छा ठीक है हम कर लेंगे। थैंक यू फॉर दैट 2 sessions and all. Thank you all the participants and hope today you all have got very good. Sir, session was too much informative and made it interactive also. And I hope tomorrow all of you will be joining at the right time at 6 o'clock. And I request you all to be present to hold throughout the session. Thank you, one and all.
So,
Thank
madam,
you, sir. Thanks.
if all can switch on the camera, we can have photograph. You can
अच्छा ठीक है sir. So participants, please can
switch
you
on.
switch on your cameras? सर वो आपका ही एक स्क्रीनशॉट लिए हम, आप जब आए ना वीडियो का एक ले लिया। हाँ
हाँ, एक ले लीजिए
अच्छा
मैडम, इसमें भी सारे पार्टिसिपेंट्स आ गए हैं, तो आई थिंक इट
हाँ
इज गुड टू सी ऑल। नमस्ते सभी को, नमस्ते मेरा।
हमको पता है वो
नमस्ते
आया ही नहीं
नमस्ते।
सर दिमाग में, तभी ले लेता ना।
फराज, सलाम वालेकुम।
Good evening, sir.
गुड इवनिंग, सलाम वालेकुम, सलाम वालेकुम।
Welcome, sir.
It's good to see
A
you
good
all.
interactive session, sir, where we're about to learn about how this technologies have been implemented in vast areas.
श्योर। और मेरा ईमेल और मेरा फोन सब मैडम के पास है, आप उनसे ले लीजिए।
जी 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 जी।
ठीक है, थैंक यू। आप सब
Okay,
मेरे से
thank
लिंक्डइन पे कनेक्ट हो सकते हैं, लिंक्डइन
okay,
पे भी
sir.
आप कनेक्ट हो सकते हैं। ठीक है, थैंक यू
Fine,
वेरी
fine.
मच।
Thank you, sir.
हिमांशी, थैंक यू, थैंक यू।
थैंक यू सर, थैंक यू सो मच। Thank you all the participants. Thank you for joining. Thank you so much.
Yes, thank you, madam.
Yeah. Thank you, ma'am. Good night, ma'am.
Thank you all.
Good night, ma'am.
Good night.